and welcome to the main event. We are getting into the fun stuff now, chemical reactions. So we're going to start talking today a little about some things that hopefully you've seen before, a little bit of balancing, and then some types of chemical reactions. And then we'll get into that for the rest of this unit. We'll talk about those different types. We'll have a lot of labs, so make sure you're not missing very much school. Now, as we start talking about chemical reactions, remember back from the very beginning of the semester that a chemical change or reaction is any change in which a new substance is formed. Okay? There has to be something new. And if you remember way back to the very beginning, there were 4 signs of a chemical change. One of those was a temperature change. And this could mean that the temperature goes up, or it could mean that the temperature goes down. And we'll look at this a little bit further as we get into it. Things that the temperature goes up in is called exothermic. That means heat is going out. And when the temperature goes down or it gets colder is called endothermic. Heat is going in, endo. A formation of a gas is another sign of a chemical change. You'll see this as bubbles being released most of the time. And formation of a precipitate. Remember, this is when the solid comes out of a liquid. So usually you'll see it get kind of cloudy. A lot of precipitates are white, so it'll go from a clear liquid to looking white and cloudy. Sometimes it's colored. You might see red chunks or blue chunks. It just depends on what the reaction is. And this last one, a change in color. This one sometimes indicates a chemical change and sometimes it doesn't. So this one is usually kind of the last thing that we look at. Now, as we're looking at chemical reactions, we write it in the form of our reactants on one side going to our products on the other. Anything that's on the right is called a reactant. Anything on the left is called a product. This arrow in the center says that it goes from reactants to products. Sometimes this will be a different sign, and sometimes there might be something written over the top of this. So there's some different symbols to know as we're talking about reactions. And here they are. So when we are writing those reactants and products, we use a plus sign to separate anything. Separate 2 reactants, separate 2 products. Sometimes you have 3 or 4 products or reactants. Sometimes you may only have 1, but we use a plus sign in between to show that they're different. You have that arrow in the middle, that means yields. Whenever we say yields, that just means that the products are going to the reactants. They're yielding the reactants or making the reactants. Sometimes you'll see an arrow like this, where it's 1 on bottom, 1 on top. Sometimes you'll see it written that way as well. This means that it's a reversible reaction. That means it can go one way, and then sometimes the products will go back the other way. These are equilibrium reactions, and we kind of get into that in advanced chem. These signs down here, S, L, G, and AQ, are all subscripts. So you will see these underneath a chemical formula. So you might see NaCl with a little S underneath. That would mean it's a solid NaCl or solid salt. If you see H2O with a little L, that means it's liquid water. If you see H2O with a G, that means that it's water vapor or gaseous water. When you see the AQ, that means a substance is dissolved in water. Water itself will never be AQ. You don't really dissolve water in water. Water is always a liquid. Then if we were to put something like salt in water, it would be NaCl AQ. That would mean that it's a solution. We've dissolved that salt into water. Sometimes above that arrow, you will see a triangle or just the word heat. That means that you have to add heat to the reaction. Some reactions won't go on their own, so we got to give it a little push. Got to heat up things a little bit. And every now and then you'll see something else written above this arrow, like PT. That stands for platinum. Platinum is a catalyst. And if you think back to biology, I know that you went over this, a catalyst is just something that speeds it up. It's like the cocaine of chemical reactions, speed. As we're talking about some speed, some reaction speed, I want you to think about what actually affects the rate of reaction when it comes to temperature. Does cold do anything to it? Does warm do anything to it? Well, if you think about weathering in different climates, if you've ever been down south, and you've ever noticed the sides of the buildings or statues around, you've probably noticed that a lot of them have like black streaks and they look really gross and they start to have holes in them. If you've ever been to Hawaii, a lot of those buildings have very like pockmarked holes. Well, that's because in cold climates, it slows reactions down. Not a whole lot's going to happen when things get cold. Kind of like when you get cold. You don't want to do a whole lot. You want to cuddle up on the couch with a blanket. Well, when things get warmer, you get faster reactions. Kind of like when it gets warm outside. You want to go outside and play. Well, when it gets warm in a reaction, they want to react. So warmer temperatures give things more energy, which means that there's more collisions between molecules. And collisions are what you need in order to initiate reactions. And I want you to think one more thing about chemical reactions. Where does everything go? I mean, you put this in, you put that in, and then all of a sudden you have something else, and it doesn't look like very much. Well, there's this nifty little rule called the conservation of mass, or the conservation of matter, which means that matter can be neither created nor destroyed. That means anything that you put in, that same amount of mass has to come out. So if you weigh everything before, weigh everything after, they should equal out. So when we write chemical reactions, we have to show this in a way. And this is why we balance equations. We have to make all the reactants equal all the products, because we can't lose or gain any atoms. So if we do a quick example here, if we take hydrogen gas and oxygen gas, remember both of those are diatomic molecules, are Hanoff-Curie, so they never are alone, H2 plus O2, we get water. This is a pretty explosive reaction. But if we take a look at what we have 2 atoms of hydrogen, 2 atoms of oxygen, so 4 atoms total, and over here we only have 2 atoms of hydrogen and 1 atom of oxygen, 3 atoms. Where'd that extra atom go? It can't just randomly go into the magician's hat so he can pull it out later. It has to be balanced. We have to put some coefficients in here to balance it out. So if we take a look, we have 1 oxygen here, 2 oxygens on this side. So we use coefficients out front to make things change. By putting a 2 out front, I change the hydrogen and I change the oxygen. This now means that I have 2 oxygens, and because I had 2 hydrogens already in it, I now have 4 hydrogens. So 2 oxygens were good. 4 hydrogens. Over here I only have 2, so I would put a coefficient out front to make that 4 hydrogens. Okay, so these numbers out front are what we use. So let's do some more practice with this. I'm going to show you kind of an easy way to get started with these balancing equations. If you can do it in your head, feel free. A lot of times as you get better at these, you can just kind of go back and forth and figure these out. But sometimes starting out, you have to write things out. So if we take a look at this reaction, NaBr plus calcium hydroxide. What I like to do is make a little table here. And let me change my color because it's not very bright. But I like to make a little table. And I like to have reactants, and I like to have my products. Okay, we have Na, we have Br, we have calcium, and we also have OH. But if you think back to your polyatomics, this is known as hydroxide. And because it's hydroxide here, it stays together as hydroxide on this side. A lot of the time it's easiest just to keep polyatomics together. If they stay together across the reaction, just keep it together and balance it as one. So those are all the things that we have to balance. So if we take a look at how many NAs we have, on our reactant side, we have 1. On our product side, we have 1. Bromines, we have 1 on our reactant side. On our product side, we have 2. Calcium, on our reactant side, we have 1. This 2 only goes with the hydroxide. There's no subscript after our calcium, so we have 1. And on the product side, we have 1. On our hydroxide, we have 2 of them, 2 hydroxides. And on the product side, we have 1 hydroxide. So to balance this out, okay, obviously we need to change our bromines because they don't balance. We have 2 over here, we need 2 over here. So we multiply that by 2. Now we have 2 bromines And we also now have 2 sodiums. Anytime that we change something, it may change something else, so we need to check that. On our sodium now, if we go back to balance it, we have 2 sodiums on this side, 1 on this side, so let's put a 2 in front of there. So now we have 2 sodiums, and we also have 2 OHs. If you haven't gotten the hint already, we do a lot of scratching out here. So sometimes it's better to do your balancing in pencil or something on the iPad that is changeable. Be ready for that. If we take a look at what we have now, we have 2 and 2, 2 and 2, 1 and 1, 2 and 2. Everything balances out. So all we needed was a 2 in front of here and a 2 in front of there. If we try it again down here on this bottom example. We have our reactants, we have our products. We have lithium, we have nitrogen, we have NH4, which is our ammonium, and it stays together across, so we'll keep it together here as well. And we have nitrate, NO3. It also stays together, so we'll keep it together as well, NO3. Lithium, we have 3 on our reactant side, and on our product side, we have 1. Nitrogen, on our reactant side, we have 1. On our product side, we're looking for nitrogen just alone, because remember we kept nitrate together and we kept ammonium together. So our single nitrogen, we have 1. Our NH4, we have 1. And on our product side, we have 3. These are 3 NH4s, not 12, 3 of these whole molecules. And our NO3s, we have 1. And on this side, we have 1. So if we take a look at our lithium, we have 3 on this side, 1 on this side, so we need 3 lithiums on our product side. So we'll put a 3 there. That means we now have 3 lithiums. We also have 3 nitrates. Anything you put in front affects what comes after. We have 1 and 1 nitrogens. We have 1 and 3 ammoniums. So to get 3 over on this side, we need to put a 3 in front of where our ammonium is. So now we have 3 ammoniums, and that also changes our nitrate. So now we have 3 nitrates on our reactant side. So 3 and 3, 1 and 1, 3 and 3, 3 and 3. It's balanced. It's a happy little reaction. Too far. All right, so as we go through this is what we're going to be talking about for the rest of this unit, is the different types of reactions. So we're going to be applying the temperature, we're going to be applying the conservation of mass, and we're going to be applying the balancing to all these different types of reactions. And you're going to learn to recognize these, and we're going to be doing a lot of these in the lab. So synthesis reactions are when things come together. And when anything is synthesized, it's the coming together of those molecules. Decomposition is when things break apart, okay? Just like when things decompose, they're breaking down. So molecules break apart into other things. A single replacement is when one atom is going to replace another. A double replacement are when 2 things or 2 atoms switch places. And the last one that we'll look at is combustion, everybody's favorite, basically burning stuff, or oxidation is another name for it. Okay, something is combining with oxygen. When we burn things, we're combining it with the oxygen in the air. So these are something to look forward to in the next couple weeks. Again, we'll be doing a lot of labs, so make sure you're in class. If you have any questions, let me know, and I will see you next time.